right, so we have gone over the basics of our four types of conics. Now what we are going to do is we are going to translate those conics, meaning we are going to shift them left, right, up, down, so that their centers or vertices are no longer at 0, 0. So I've got all of the different equations for you here, how they're going to look different now that we are translating them. Basically, instead of just x squareds and y squareds, we now have x minus h's, y minus k's. And that, of course, should be familiar because we've had x minus h, y plus k's for various parent graphs along the way this year. So here's our circle. Again, the only thing that's changed is that we are shifting both the x and the y, meaning this is going to represent your horizontal shift. This is going to represent your vertical shift. So the h always is horizontal shift, and k is your vertical shift. So once we have that, I'm going to write in here too, just because I think it's nice to have it on all of your various sets of notes, the equation for ellipse and hyperbola to find your foci. So here are those. And then I've got a couple hints in here at the bottom, which we'll refer to as we go. But obviously HK is going to be the vertex for parabola. It's going to be the center for all your other conics. Remember that the center of an ellipse or hyperbola is going to be the midpoint of the major axis. So if you know where your center is and you know your A or your B, you count that many spaces in either direction. P still represents a distance. It's how far it is from the vertex to the focus as well as to the directrix. So just a whole bunch of hints here that can help you as you go along. So first thing we want to be able to do is write an equation for the conic, and we've got various pieces of information given. So we've got a circle with center 4, -1 and radius 7. So we look at our equation for a circle, we do x minus h squared plus y minus k squared equals r squared. So x minus, this is h, this is k, because we talked about that here, x minus 4 squared plus y minus -1 squared equals r squared. So we're always going to write everything in simplest form. So x minus 4 squared plus y plus 1 squared equals 49 would be our final equation for that circle. Next, we have a parabola with vertex 3, 2 and directrix y equals 6. I usually just do like a little rough sketch. It doesn't have to be perfect, but 3, 2 is going to be, you know, about right here. I don't even make the slashes necessarily. So that's my vertex. My directrix is y equals 6, so that's going to be somewhere up here. The reason I do that is because that visually tells me which way this is going to open. Because if I know where my vertex is, the directrix is always in the opposite direction of the opening. So that means that this one, I know for sure, opens down. So when I do that, that tells me multiple things. That tells me that the x variable is going to be the squared one and that it's going to be negative. So the x, h value is 3, k value is 2. So I know since x is going to be squared, that's over here. So x minus 3 squared equals, I know it's going to be negative, but I need to find what my 4p is. And you can get that from this sketch as well. If this is at 2 and this is at 6, that means that the distance between those is 4. That's your p. So p is 4. That means that 4p, of course, would be 16, and we know it's negative. So negative 16, and then I can do my y minus k, which is 2. So there is my equation. All right, I've got an ellipse with vertices at 4, -8, and 4, 4, and covertices at -1, -2, and 9, -2. So this one I'm definitely going to have to graph to figure out exactly what I'm doing here. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, -2. So there's a covertex, -1, -2. It's another covertex. And then I've got 4, -8. So right here, and 4, 4. So it almost looks circular, but that is an ellipse. So my vertices tell me which axis is major. So this is my major axis here going through x equals 4. That's my major axis. So if I figure out how long it is, it's 4 units from the x-axis up and it's 8 units from the x-axis down. So the major axis is 12 units, which means that half of that is 6, and that's going to be my A value because A is always the bigger value. Now if I look to find my B value on the minor axis, here in red is my minor axis. This was 9 and this was -1, so that means my minor axis is 10 units, which means half of that gives me my B, which is 5. So now I just need to figure out where that center is. So halfway between my vertices and or my covertices is going to be my axis. So if it's 12 units, that means I go 6 units in. It's where the two axes intersect. So it's going to be at 4, -2 is going to be my center. So that helps me write it. I know that it's going to be x minus 4 squared right here. I know it's a plus sign. Y plus 2 squared. I know it's going to be equal 1. And then down here I need to put my a squared and my b squared. Remember that a is always the major axis. So in this case the y-axis is longer, the vertical axis. So a squared would be 36, so that goes under my y. B squared is 25, and that goes under my x. So here is our equation. D, a hyperbola with vertices at 5 plus or minus 4 and foci at 5 plus or minus 6. So again, probably need to sketch this in order to have an idea of where it's going. So 1, 2, 3, 4, 5, and 4. And 1, 2, 3, 4, 5, 6, and up to 4. Here are my vertices, 5 plus or minus 4. My foci are at 5 plus and minus 6. So foci right here. So I know, because again, your foci have to be on the inside of the branches, that it should look something like this. So the center has to be halfway between those two vertices. So if they're at positive and -4, that means that my center is going to be on the x-axis. So my center here is at 5, 0. And that's obviously immensely helpful in writing the equation because that's my h as well as my k. So now I need to figure out what my a and my b are. So when you have the hyperbola, you know that the vertices are a away from the center. So when I look, here's my center, here's my vertices, so that means that a has to be 4 because each of my vertices are 4 units away from my center. So A is 4. If I know where my focus is here, C is the distance from my center to my focus. So I know that C has to be 6. And because this is a hyperbola, I know that c squared equals a squared plus b squared. So 6 squared equals 4 squared plus b squared. So 36 equals 16 plus b squared, which means that b squared is 20. And that's the missing piece. That's all that I need, because now I know what b squared is. I don't need to know b, which is just the square root of that, but here's b squared. Now I know what a squared is going to be. A squared is 16. So once I've got that and I know which direction it opens, that means that I can write my equation. I know that this hyperbola, because it opens up and down, I know that it's going to have the y value first. So y minus 0 squared, you don't have to write the minus 0 squared, over my a squared, which is 16, minus, and then x minus 5 squared, over b squared, which is 20, equals 1. And there we go. All right, so we've taken the characteristics and written the equations. Now we just need to make sure we can identify the conics and their important characteristics. I've listed here what you need to make sure that you list with all of these. So on a parabola, you need the vertex, the focus, directrix. Make sure you have 2 other points specifically plotted. You don't have to list them, but they have to be specifically plotted. Circle, just the center and radius. Ellipse, center, vertices, covertices, and foci. Hyperbola, center, vertices, foci, and asymptotes. So we're going to graph each conic and identify the important characteristics. So first one, x minus 3 squared plus y plus 5 squared equals 16. So if I look at that, I see that both the x and the y are squared, and there's no denominator here, and there's no numbers in front that would require me to divide by this 16. So that means that this one's a circle. So my important characteristics are its center, which is at 3, -5, and its radius, which is going to be the square root of 16. So there's my important characteristics. Now I just need to put it on the paper. So 3, -5, with a radius of 4. So 4 units in all my directions. And I'll do my best to make it look circular. Not terrible. All right, there we go. Circles are the easiest ones. B, x plus 7 squared equals 12 times y minus 3. This one, only one of the variables is squared, so that tells me immediately that this is a parabola. So if I'm looking at the important characteristics that I need to list, I need the vertex, focus, directrix, and then 2 other points. So my vertex here is going to be at -7, +3. This 12 tells me the value of 4p, which means p itself is 3. So that means that my focus and directrix are going to be 3 units away from my vertex. Now, I should probably figure out which way this opens. If the x is squared and it's positive, that means that this opens up. That's important because I should probably know where my focus and directrix are before I plot them, because if you start plotting it and then have to change your scale, you're going to be mad when you have to erase or use whiteout. So figure out where they are first before you put them on the graph. So if it opens up, that means my focus is going to be moving away from the vertex on the up value. So it's still going to have an x value at -7. But because it opens up, I'm going to go 3 units higher than 3 to get my focus. My directrix, in similar fashion, I know that my directrix is a y equals line because of the direction of my opening. I'm going to go 3 units the other direction, and y equals that value. So if I have the vertex at 3, 3 units down would be 0. So that means it's y equals 0. You could also write x-axis for the directrix. So it looks like all of those things are going to fit even if I count by ones. So -7, 3, 1, 2, 3, 4, 5, 6, 7. There is my vertex. My focus is going to be 3 more up, and my directrix is going to be down here. Now to get my opening, I need to plot those other 2 points. If 4P is 12, that's my lattice rectum. The lattice rectum is 12 units, which means it's 12 units wide at the focus, 6 on each side. So I go to my focus and I go 6 units right, 1, 2, 3, 4, 5, 6, and 6 units left, 1, 2, 3, 4, 5, 6. Oh, did not connect that very smoothly. Hopefully yours looks better than mine. So there is our parabola. All right, next one, x squared over 16 minus y plus 4 squared equals 1. So this one has subtraction, and they're both squared. And if I multiplied by 16 to get rid of this, I would end up with a 16 in front here. We know that this has to be a hyperbola. This one doesn't have a denominator on the y, which means that the denominator is 1. So that helps us out. Now we just need to get our important information so that we can figure out how to graph it. So I know that because the x squared came first, that this has to be a horizontal hyperbola. And because the x squared comes first, that tells me that my a value has to be the square root of 16. So a is 4, which means that b is going to be 1. So my center, there is no minus on the x squared. So no horizontal shift here, but there is vertical shift down 4. So 0, -4. And it looks like when I created my coordinate plane, it got a little off with the grid. Sorry about that. So 0, -4 there. And I should not have plotted that yet. I just told you not to do that. I'm not sure why I did that. So our center is at 0, -4. Now, my vertices are going to be A away from that center. So on the x-axis, because this is a horizontal hyperbola, I'm going to go 4 units in either direction. So this time, I can just leave because it's starting at 0. I can make my vertices +4, -4, and -4, -4. So I'm just going to write it with a plus and minus. You're not always going to be able to do that. If this were an actual value other than 0, you'd actually have to add the 4 and subtract them 4 and write them separately. But in this case, we kind of luck out. So vertices go at +or -4, -4. Then I need to find my asymptotes as well as my foci. So my foci, because this is a hyperbola, again, you can go back up and look, your hyperbola is a squared plus b squared. So c squared equals a squared plus b squared. So c squared equals 16 plus 1, which means c squared is 17, and c is radical 17. So remember, foci are on the inside of the opening, so it's from the center and past the vertices. And again, because my center had a coordinate of 0, we kind of get lucky and we can just say they're going to be at plus and minus radical 17, -4. Again, if this weren't 0, we would have to do 2 plus or minus radical 17, something like that. So here are my foci. Now I just need my asymptotes. And these ones are a little trickier. I know that my asymptotes have to go from the center. And since my center y-intercept is at -4, that's going to be the intercept of my asymptotes. So now I just need the slope. And remember, the slope is always the y value over the x value and the square roots. So the square root of 1, which is 1, over the square root of 16, which is 4, x, and then because it's coming out from the center, that means that my y-intercept is going to be -4 on those asymptotes. So if I look at these, again, it looks like I've given enough room where these are going to fit, and I can go ahead and plot them. So here's my center. So my vertices are going to be 4 over in both directions. Then my asymptotes, I'm going to use a slope of 1/4, so up 1, right 4. Remember that these make a box around your vertices and center. And so connect those. There's one asymptote. And I missed a little on that one, sorry. There's the other asymptote. So that tells me that the openings are about this wide. And then the last thing to plot are my foci, which again, if you don't have a concept for how big radical 17 is, then punch it into your calculator. It's a little bit bigger than 4. So they're just, and because I missed when I connected here, you're barely going to be able to see it, but it's just past the vertex on either side. All right, last one. If I look at this, x and y are both squared. They've got denominators. It's equal to 1. This one has to be an ellipse. So when I look at an ellipse, remember whichever number is bigger, that's my a value. So I can say here that a is going to be the square root of 100, or 10. B is going to be the square root of 25, which is 5. That's going to help me because I can use that to find my foci. C squared equals a squared minus b squared. So 100 minus 25. So c squared is going to be 75, which means that c is 5 radical 3. So now I need to graph this, which means my important characteristics for an ellipse, I need the center. So the center is going to be at 6, 2. My vertices, because what's under the y is bigger, that means the major axis is the y. So my a value is 10. That means I'm going to go 10 units up and 10 units down to find my information here. So 10 units up from the center for the vertices. 10 units up would be 12. 10 units down would be -8. My co-vertices, my b value is 5. And so from the center, this is the minor axis, which is going to be the x-axis. So on the x-axis, I'm going to go 5 up and 5 down from the 6. So 5 up would be 11, 2. 5 down would be 1, 2. So I've got center, vertices, co-vertices. Now I just need my foci. And I already found C. So remember, foci are on the major axis. So from the center, I'm going to be going up 5 radical 3 and down 5 radical 3. Since those don't simplify, you can just put plus and minus there. So here are all my important characteristics. Now I need to graph it. Now, I don't know that we have enough room to graph all of this because we'd have to go down to -8. Let's see, 3, 6, 7. I guess if we don't mind, going one off the page, but we have to go up to 12 and 3, 6, 9. That'd be 2 off. That's just too much. So we are going to count by 2s here in order to fit it on. So my center is 6, 2. So that's going to be right here. My vertices, 6, 12. So 2, 4, 6, 8, 10, 12. And 6, negative 8, 2, 4, 6, 8. So there's my cis. My minor co-vertices, I've got 11, 2, so 2, 4, 6, 8, 10, halfway. So here's 11, 2, and then 1, 2 for my minor axis. So that allows me, whoa, that is not a good looking ellipse. Sorry about that. Pen's getting stuck on top of it being hard to connect. So it's a sad looking ellipse. Hopefully yours looks a little bit better than mine. Most of us don't know what 6 plus 5 radical 3 is. So punch it into your calculator. It's about, let's see, right on the inside here. What in the world did I do? I did not list this right. Okay. Because my foci should be on my major axis, and that would have them on my minor axis. No wonder that didn't seem right. All right, let's fix my foci here. So from the center, they're on the major axis, and I said that, but then I did the wrong one. They should be 6, 2 plus or minus 5 radical 3. I was wondering why that didn't look like it was plotting in the right place. So now, if I do 5 times radical 3, and then add 2 to it, now it should look right, 10.66. So 2, 4, 6, 8, 10, which is why I was looking at my graph and I have it plotted in the right place, but certainly I couldn't figure out why it was not working for the actual value I was getting. And so now we know. So the other one is like negative 6 point something, so 2, 4, 6 right down here. So there are our foci. All right. I think that wraps it up. Sorry so long.